Hello everyone! When I was preparing for this lecture, I thought it would be quite challenging to fit such a large amount of new concepts into one lesson. But what if we break down today's topic using dragons? What do dragons have to do with AI frameworks, you might ask? Get comfortable and let's recall an amazing animated movie. How to Train Your Dragon. If you haven't watched it or forgot the plot, let me tell you this story. There once lived a young Viking named Hiccup in a tribe where everyone fought dragons, but such traditions weren't quite close to our main character's heart. At some point, Hiccup realized something important. Instead of fighting, you can study dragons and befriend them. That's how he met a Night Fury, the rarest and most dangerous dragon, and named him Toothless. What amazes me about this story is how Hiccup approaches training Toothless. He has his own workshop full of tools. There are blueprints, diagrams, ready-made parts for creating saddles and harnesses. There are training methodologies that he develops and improves. And most importantly, Hiccup doesn't invent everything from scratch. He uses his tribe's knowledge, existing tools, but applies them in a completely new way. That's exactly how AI development frameworks work. These are sets of software tools and libraries used to create, train, and deploy AI models. Imagine, Hiccup is you, a developer or QA engineer. Toothless is the AI model that needs to be created and trained. And Hiccup's entire workshop with tools, blueprints, and methodologies. That's the AI development framework. Why don't we write AI systems from scratch? Imagine if Hiccup had to reinvent a hammer, saw, and nails every time. That would be insane. Modern frameworks give us ready-made solutions for data preparation, like ready recipes for dragon food. They provide algorithms like proven training methods, and they can compile models to work on different hardware, from regular CPUs to powerful GPUs and specialized TPUs. By the way, let's quickly understand this hardware, because it's important for understanding frameworks. CPU is a central processing unit, the computer's brain. It excels at sequential tasks like an experienced craftsman who does everything step by step. GPU is a graphics processing unit, originally created for graphics processing. But it turned out to be ideal for machine learning because it can perform many simple calculations simultaneously. It's like an entire team of helpers working in parallel. TPU is a specialized processor from Google, created specifically for machine learning. It's like a tool made precisely for a specific task. Now let's get acquainted with the tools in the workshop. Popular frameworks. Let's start with TensorFlow from Google. It's like Hiccup's universal workshop, powerful, reliable, with a huge community of craftsmen worldwide. TensorFlow is excellent for scalable machine learning projects. It has amazing documentation and plenty of learning materials. But there's a nuance. Beginners might find its complexity challenging. It's like a professional workshop, lots of capabilities, but you need time to learn how to use everything. For testers, it's important to know. TensorFlow-based systems can behave differently depending on the version. Always check compatibility. PyTorch from Facebook is like a researcher's workshop. It's more flexible and intuitive, especially for experiments. PyTorch supports dynamic computational graphs, which simplifies development and debugging. This is especially useful for computer vision and natural language processing tasks. Imagine Hiccup being able to modify the saddle designs while flying. But there's a catch. Deploying PyTorch models to production might require additional effort. Keras is like a simple and convenient toolkit for beginner craftsmen. It's a high-level Python API that works on top of TensorFlow and CNTK. I'll tell you about this a bit later. Keras is designed for rapid model prototyping. It's simple and intuitive, perfect if Hiccup is just learning to work with dragons. But if you need deep customization or specific optimizations, Keras might be too simple. Scikit-Learn is a classic toolkit for traditional machine learning, like a reliable hammer and saw in Hiccup's workshop. Simple but effective. It's excellent for classification and regression tasks, has many built-in algorithms and data preprocessing functions. But for deep learning or working with big data, Scikit-Learn isn't suitable. Now let's talk about more specialized tools. Apache MXNet is a flexible framework that supports multiple programming languages: Python, C++, Java. It scales well and is optimized for GPU. It's like a universal tool that craftsmen from different countries can use, but it has a smaller community, so there might be insufficient learning materials. CNTK, or Microsoft Cognitive Toolkit, is known for its speed in model training. It's especially good with sequential data like speech. If you're already using Microsoft technologies or Azure, CNTK integrates easily into your environment. But user community activity is lower. IBM Watson Studio is an entire platform for developing AI solutions. It offers a convenient interface, team collaboration tools, and even automatic modeling with AutoAI. It's like a fully equipped factory, not just a workshop. Great for large projects, but beginners might find setup complex. And before we go further, I'd like to make an important clarification. Unfortunately, the data in the ISTQB Tester AI syllabus we're following is somewhat outdated, as the certification appeared back in 2021. If you're taking this course only to pass the certification, you can skip the next part. Meanwhile, I'll tell you about what's happening with frameworks now. In recent years, the world of AI frameworks has changed dramatically. Imagine Hiccup's workshop suddenly receiving an entire arsenal of new, incredibly powerful tools. And most importantly, tools for creating what are called AI agents have appeared. What are AI agents? Let me explain in simple terms. Previously, AI systems were like trained animals. They could execute specific commands. Ask a model to translate text. It would translate. Give it a picture. It would describe it. An AI agent is like an intelligent being that can make decisions independently and perform complex tasks without constant human guidance. Imagine Toothless transformed from just a trained dragon into an intelligent companion who can analyze situations independently and make decisions based on that analysis. He can use various tools to solve tasks, remember previous experience and learn from it, and of course he can interact with other dragons to solve complex tasks. For example, instead of simply saying "find weather information," you can tell an AI agent, "help me plan a weekend picnic," and the agent will check the weather forecast, find suitable picnic spots. It will check if these places are open on weekends and compile a list of necessary items for you. It can even book a spot or order products. It's like Toothless being able not just to fly on command, but to plan routes himself, consider weather, find safe landing spots, and coordinate actions with other dragons. The first modern revolutionary is LangChain. If our traditional frameworks helped train dragons, LangChain taught them to talk. LangChain is a framework for creating applications with large language models, or as they're called LLMs, large language models. What are large language models? These are AI systems that understand and generate human language, like ChatGPT, for example. LangChain allows creating action chains. Imagine Toothless can now read a letter from another tribe, understand what it's about. He can find necessary information in archives, compose a reply letter, and send it to the addressee. Previously, each action required a separate command. Now you can say "process incoming correspondence," and the entire chain will execute automatically. And in 2024, LangGraph appeared. It's like Hiccup learning to coordinate an entire flock of talking dragons, each performing their role in a complex mission. LangGraph allows creating stateful, multi-agent applications. What does stateful mean? It means the system remembers everything that happened before, like each dragon remembering all previous missions and being able to use that experience. LangGraph is essentially an entire team of AI agents working together, passing information to each other and remembering context. The second revolutionary is Hugging Face. Continuing our analogy, Hugging Face is like a huge library of all known dragon species, with training instructions and ready methodologies. Hugging Face started as a regular chatbot company in 2016, but then they realized they could bring more benefit by sharing their AI technologies with others. Today, Hugging Face is a central ecosystem for AI. Imagine a gigantic online library with over 1 million ready AI models, plus 190,000 training datasets and 55,000 demo applications you can try right in your browser. This isn't just a framework, it's an entire universe of AI tools. Hugging Face's main treasure is the Transformers library. What is it? Transformers are ready, pre-trained AI models that can work with text. They can translate languages, answer questions, analyze text sentiment, generate new texts. Imagine Hiccup's library having an entire collection of already trained dragons. One specializes in reconnaissance, another in translating neighboring tribes' languages, a third in analyzing ancient scrolls. How popular is this? Their Transformers library has over 121,000 stars on GitHub, more than PyTorch, and the platform receives 18.9 million visits per month. What makes Hugging Face special for us? Imagine instead of training Toothless from scratch, Hiccup can choose an already trained dragon from a huge collection who knows exactly what's needed. Want a model for analyzing customer reviews? Here you go. Need a translator for 200 languages? Available. Need a code generation system? Take it. 92% of models on Hugging Face work with PyTorch and only 8% with TensorFlow. This shows where the industry is heading. Now, there are tons of new developing frameworks that work specifically with AI agents. I won't tell you about each one now, but you can later familiarize yourself with services like CrewAI, AutoGen, and JAX from Google. CrewAI specializes in creating teams of AI agents with different roles. AutoGen was developed by Microsoft. It's a system for creating multi-agent dialogues. And JAX is a framework mostly for scientific computing and machine learning. It's ideal for tasks requiring maximum performance. This could be weather modeling, physics research, it could be developing new neural network architectures or training very large models. It's a tool for cases when standard frameworks work too slowly. So, how does this change the concept of testing for us? Now we test not just models but entire agent ecosystems. What does this mean practically? First, it's interaction testing. We need to check how agents communicate with each other, whether they correctly pass information. Second, state testing. It's important to ensure the system correctly remembers context and uses it in further work. Decision-making testing will also be important. Here we need to understand why an agent made exactly that decision and whether it meets expectations. And finally, reliability testing. What happens if one of the agents crashes or gives a wrong answer? How do we choose the right framework in modern realities? Let's sum up. For classical machine learning, it's still TensorFlow, PyTorch, Scikit-Learn. For creating chatbots and language applications, LangChain and models from Hugging Face will help us. For AI agent teams, CrewAI works well for simple tasks, LangGraph for complex workflows, and AutoGen suits research. For maximum performance, JAX is good to use, especially for scientific tasks. For rapid prototyping, Hugging Face plus Keras will suit us. So, the world of AI frameworks recently isn't just Hiccup's workshop anymore. It's an entire civilization where dragons learn to talk, work in teams, make complex decisions independently, and even argue with each other to achieve better results. Classical frameworks haven't gone anywhere. TensorFlow and PyTorch remain the foundation. But an entire ecosystem of tools for creating truly intelligent systems has grown on top of them. We live in an era when AI is transforming from simple tools into intelligent assistants. And as QA professionals, we must be ready for this new reality. In the next lecture, we'll talk about what hardware all these AI dragons and agents need for full-fledged work. We'll discuss hardware for AI-based systems. After all, even the smartest agent needs powerful infrastructure for thinking. See you next time, and thank you very much for watching this lecture to the end.